Hello, in this video I'm going to talk about how to plot the graph of a quadratic equation. The general form of a quadratic is y equals ax squared plus bx plus c. Can also be written as f of x, the function of x, equals ax squared plus bx plus c. It's the easiest way to plot the graph of a quadratic is to create a table of values. I've seen people create a table of values as follows, where they will have x values at the top running horizontally here, and then so for instance if we had the example y equals x squared minus 3x minus 4, they'll have the x terms running across the top here. In the second row they'll have x squared, and then in the third row they will have minus 3x, and then the next row they have negative 4, the constant, and then the y value. So for example, if x equals negative 2, you would plot for the relevant x value in this column. Okay, so x squared, well, negative 2 squared is 4. Negative 3 times negative 2 is 6, and this is just negative 4, that's the constant c, and then so y would equal in this case 6. 4 plus 6 is 10, minus 4 is 6. So you'd have you'd have your x and y value. Your x value would be negative 2 and your y value would be 6, and you would essentially do this for all the x values that you needed to find in terms of the correlating y value. But I prefer a much more simple approach. I think that is a little bit superfluous, really. I'll consider the example, a simple example in this video. Say we are given that y equals x squared minus 3, and we need to take the values of x from negative 4 to positive 4. Okay, so first thing that we could do is, again, we can create a table, and I'm just going to create a more simple table of values where we just mark this as x, and then this is y equals x squared minus 3, and so we need to take the values from the values of x from negative 4 to positive 4. So we'll start with negative 4. So x equals negative 4. So this is going to be negative 4 squared minus 3. So that's 16 minus 3, which is 13 in this example. So this is x equals negative 3. So it's negative 3 squared minus 3, which is going to give us 6. 3 times 3 is 9, minus 3 is 6. In this this is negative 2, so x equals negative 2. So it's negative 2 squared minus 3, which is going to give us 1. Because negative 2 squared is 4, minus 3 is 1. And then in this one we have negative 1. Negative 1 squared is just going to be 1 minus 3. So 1 minus 3 is going to be negative 2. And now we're at the origin, in which x equals 0. So it's 0 squared minus 3, which is going to be negative 3. And see if I can fit it all in here. We have, actually I might create a new table of values for positive x values because there's not enough room. So it's x, this is still y, equals x squared minus 3, so we'll start off from 0, so it's going to be 1, x equals 1, so it'll be 1 squared minus 3, again, that's just going to be 1, and 1 minus 3 is negative 2, now x equals 2, so it's going to be 2 squared minus 3, which is 4 minus 3, so it's going to be 1. And one will notice a certain pattern emerging here. You can see that we moved from 1 y equals 1. When x is negative 2, y equals 1. When x is negative 1, y equals negative 2. And then when x is 0, y equals negative 3. We're moving in a pattern where we're moving from y equals 1 to negative 2 to negative 3. And now we're moving from negative 2 to y equals 1. And so one might be inclined to predict that when x is 3, y is going to be 6. So when x is 3, 3 squared is 9, minus 3 is indeed 6. And likewise for our final x value, x equals 4. So 4 squared minus 3, that's going to be 16 minus 3, which is 13. And so there is a very clear pattern, and it makes sense when we plot the graph. We do have some negative values, so I'll draw the graph like this. Okay, this is the x-axis. 1, 2, 3, 4. It's going to look something like that. And 1, 2, 3, 4. It's negative 4, negative 3, negative 2, negative 1. And this is 1, 2, 3. So it's negative 3, negative 2, negative 1. And we go as high as 13 on this graph. 1, 2, 3, 4, 5, 6. There's nowhere near enough space. So actually what I'm going to do is I'm going to make the y-axis multiples of 2. So that's negative 2, that's negative 4, that's negative 6. It's 2, 4, 6, 8, 10, 12, 14. Okay, so that's the y-axis. I don't have enough room to label it, but yeah, that's the y-axis. Right, so when x is negative 4, this is 2, 4, 6, 8, 10, 12, 14. When x is negative 4, y equals 13. So negative 4, 13 is going to be right here. It's going to look something like that. When x is negative 3, y equals 6. Negative 3 and 6. When x is negative 2, y equals 1. So negative 2, 1 is going to be right in the middle here, like that. X is negative 1, y equals negative 2. So negative 1 is negative 2. And when x is 0, y equals negative 3. So that's our y-intercept, where the graph crosses the y-axis, is at negative 3. And now when x is 1, y is negative 2. And I might actually, maybe I'll mark the points in red so it's a bit easier to see, like so. When x is 2, y is 1, so again it's going to be right there. When x is 3, y is 6, so it's going to be right there. And when x is 4, y is 13. It's going to be somewhere right there. And so when I draw this, it's going to look something like this. And you can already see that this graph is a healthy parabola, which is synonymous with quadratics. Okay, parabolic shape, which is symmetrical. And that leads to the second point, where the line of symmetry, is in essence, it is always halfway between the x-axis, or between the x-axis crossing points. Okay, or the roots, you could say. It's always halfway between the real roots, or solutions to the quadratic. I will explain that in a moment. And so the line of symmetry, I'll write it here, line of sim. The equation for the line of symmetry is going to be x equals 0. Okay, because the line of symmetry, which I will mark in magenta, is the y-axis in this case. Goes right down, splits the middle. Okay, so symmetric. And in terms of the roots, you can denote in green. It's going to be right there and right there. To find the roots, you just have to basically solve this this quadratic. So I'll do that up in this space here, where y equals x squared minus 3. basically just going to want to set this to equal 0. Okay, and then we're going to add 3 to both sides, which is just basic algebra. So it's going to be x squared equals 3. Take square root of both sides, so you're going to get, that cancels out here, so you're going to get x equals plus minus root 3. And that looks like it is correct, because root 3 is 1.7, I believe. Just going to plug that into my calculator to make sure. Root 3 is 1.73205. Okay, so that looks correct, 1.73205. And yeah, so that's the basic technique on how to plot quadratics. In a future video, in the next video, I will work on a few more examples.